Having spent almost half a century floating silently across the unimaginable expanses of interstellar space, Voyager 2 has again shocked the scientific community. In an announcement recently made that sent shockwaves through astrophysical circles around the world, NASA revealed that the probe, over 12 billion miles from home, sent back new information reporting what scientists have openly referred to as an impossible discovery inside their own ranks. This is not hyperbole or scientific hyperbole. It is a science outlier when decades of modeling, simulation, and theory are put into question by a sequence of unpolished, unanticipated figures beamed from a distant probe that most had almost remembered was still going. What Voyager 2 discovered upends everything we previously believed about space outside of our solar system. The revelation is so deep that it has compelled scientists to re-examine basic assumptions concerning the form and function of interstellar space, those enigmatic realms where the sun's pull tapers away and the greater galaxy starts to exert its dominance. Released in 1977 under the Carter administration, Voyager 2 was originally intended to perform a grand tour of the gas giants Jupiter, Saturn, Uranus, and Neptune. That main mission was a blockbuster success, providing humanity with the first close-up glimpses of those far-off worlds. But no one could have foreseen the amazing longevity of this spacecraft. Once it had finished exploring the planets, Voyager 2 pushed on, pursuing its work well beyond the bounds of its initial mandate. Decade after decade, it has journeyed further into the unknown, acting as humanity's eyes and ears in the interstellar medium. Now moving in an area known as the heliopause, the edge at which the sun's solar wind no longer reigns supreme, Voyager 2 is providing scientists their first direct experience of interstellar space. And the experience, it seems, is electric, churned, and deeply alien. For decades, the general assumption was that interstellar space, beyond the shielding bubble of the heliosphere, would be quite quiet. A cold, tenuous emptiness, quiescent, peaceful, and unvarying. Voyager 2 has shattered that vision. Rather than quiet, the spacecraft has measured evidence of active action, intricate magnetic field reversals, weird plasma oscillations, and sudden changes in cosmic ray intensities. Perhaps the most surprising discovery is the wildly unpredictable actions of magnetic fields just outside of the heliopause. Previous models predicted the fields would lie smooth and regular, sculpted by the slow, steady flows of interstellar medium. But Voyager 2 has come back with fields that curve, loop, and change direction in ways that defy understanding. The distortions were not fleeting or random, they were persistent patterns, indicative of a more profound, more disordered structure to the space we assumed was empty. Even more perplexing were the rapid upswings and downturns in high-energy cosmic rays. Instead of a smooth break into interstellar space, Voyager 2 detected extreme, sudden shifts in cosmic ray fluxes. These oddities suggest something not previously included in accounts, perhaps clumps or barriers in space, features that may be affecting the flow of such energetic particles. It was as though Voyager 2 were sailing through walls or veils that could not be seen, indicating that space is much more ordered than had been thought. Plasma, the electrically charged form of matter that characterizes both solar and interstellar surroundings, also acted in terms that astonished scientists. Voyager 2 found areas of plasma that pulsed and oscillated with unexpected vitality and periodicity. Far from being diffuse and peaceful, these waves showed harmonic structures that hinted at interactions with elusive structures or forces. The existence of such plasma harmonics would suggest boundary layers or interference by deep space structures such as ancient supernova remnants or gravitational wave echoes. Some theorists have even ventured to speculate on gravitational lensing effects from dark matter clumps or stray planetary objects lurking in the emptiness. If true, these discoveries redefine the whole paradigm of what interstellar space is. Instead of a desolate vacuum, space outside the solar system might be more akin to an ocean, now with currents, turbulence, and layered zones of pressure and energy. This analogy has profound consequences for how we simulate galactic motion, cosmic radiation, and even the formation of stars. One of the deepest, most intriguing possibilities opened up by the data is the presence of interstellar filaments, tenuous, thread-like plasma structures that are similar to the large cosmic web seen on galaxy scales. Should Voyager 2 have traveled through one of these filaments, it would be the first direct, in situ confirmation of their occurrence at the boundary of our solar system. These filaments, made up of charged particles and magnetic fields, could be cosmic highways for matter and energy throughout the galaxy. Knowledge of these structures would not only revolutionize the way we research space, but also the way we look for planets and life. How plasma and magnetic fields interact can affect planetary system formation. Regions with high concentrations of interstellar structure may promote more advanced environments where stars and possibly habitable planets come into being. And then there's the search for life itself. Voyager 2's findings also give new life to the panspermia theory, the notion that life can travel from one planetary system to another through asteroids, comets, or dust grains. With interstellar space being more active and less deadly than scientists once believed, it is easier to envision microbic life catching a ride through the universe. Rather than a barren vacuum, the areas in between stars may be favorable to the dissemination of life. Charged plasma waves and structured magnetic fields may even shield or steer such matter along its path, serving as galactic delivery vehicles for life's constituents. On Earth, scientists are sifting through the terabytes of data being returned by Voyager 2. Each packet is a piece of a puzzle, and the larger picture grows increasingly shocking by the day. The spacecraft's instruments, many of them approaching 50 years in age, continue to operate with awe-inspiring accuracy, measuring faint variations in particle density, temperature, and magnetic inclination. Even though it has been functioning in near absolute zero temperatures and sending messages over billions of miles, Voyager 2 still provides insight after insight. What is so amazing about all of this is the plain fact that Voyager 2 was never intended to last this long. It was built by engineers with an expected mission life of a couple of decades at most. And yet here it is, still plowing into new and untapped space, rewriting textbooks along the way. This raises fundamental questions about the longevity of technology, the worth of long-term investment in space travel, and the surprises that lie in store for us when we take the courage to stretch as far as beyond our immediate reach. And these are not merely esoteric scientific discoveries. The implications extend into the very future of human space exploration. It is only by learning the real nature of interstellar space that we might ever successfully send spacecraft, or even humans, beyond our solar system. If space is permeated by violent magnetic structures and changing cosmic ray fields, then missions in the future will require much more sophisticated shielding, intelligent navigation systems, and adaptive propulsion schemes. Voyager 2's findings are already being implemented into the planning of future generation missions such as the Interstellar Probe mission, which would go even further into the galaxy. In addition, these results will redefine satellite shielding, space weather forecasting, and astronaut protection on long-duration space flights. Radiation exposure poses one of the biggest risks to human Mars and interstellar exploration. If interstellar radiation's behavior does not match assumptions, we'll have to drastically revise our models and protective measures. Even our knowledge of stellar evolution may be affected. Stars like the Sun communicate with their environments using magnetic fields and solar winds. If Voyager 2 has already demonstrated that the heliopause is not a smooth, spherical interface but a distorted and interactive region, then it revolutionizes the way we perceive other stars' engagements with interstellar space. This might even influence the way we interpret observations by telescopes looking at faraway exoplanetary systems. And finally, perhaps most poetically of all, is the reminder that the universe remains full of secrets. Voyager 2, a spacecraft constructed when the internet didn't exist, has traveled beyond the safety of our star's cocoon and discovered that the emptiness is not empty. It throbs. It vibrates. It shifts. The fact that something started with 1970s-era computing is now putting 21st-century science to the test is both humbling and inspiring. In an era where immediacy of information and quick technological turnover are the norms, Voyager 2 is a testament to persistence of inquisitiveness. It echoes back from the void, reporting tales unknown to any telescope, unguessed by any model. And as it journeys on into the void, it bears with it the common optimism of a species bent on comprehending the universe. So what does this mean for you, the viewer, the dreamer, the future explorer? It means that space is not a dead frontier, it's alive, waiting, and full of secrets. And every piece of data Voyager 2 sends back is a beacon of possibility, a reminder that exploration is far from over. In fact, it might just be beginning. If you like this in-depth look at Voyager 2's impossible find, be sure to like this video, subscribe for more amazing space videos, and share your opinions in the comments section below. Do you think Voyager 2 has discovered anything? Are we on the threshold of rewriting the history of space as we know it? Let us know. Thanks for watching, and we'll catch you in the next adventure beyond the stars.